In this problem, we're going to solve an inequality. We're going to graph the solution set on a real number line and express the solution in interval notation. Well, let's look at our inequality. It's x squared minus x is greater than or equal to 12. Well, what type of inequality is it? If you see, the highest degree on the x is a 2, so it's quadratic inequality or a polynomial inequality. And the way we solve those is using the boundary point method. So the first thing I've got to do is find the boundary points for this inequality. And what we want to do is we want to get everything on one side initially. So I'm going to have to move the 12. So I'm going to have x squared minus x minus 12, subtract 12 from both sides, is greater than or equal to 0. So now I have all my terms on one side, 0 on the other. So now I am ready to find the boundary points. And the way we find the boundary points is by changing this inequality to an equal sign over here. As you can see right here, I've turned the greater than or equal to into an equal because we know how to solve a quadratic equation. So what we're going to do is we're going to solve this quadratic equation. So it's a simple quadratic equation, everything on one side, 0 on the other. Leading coefficient is a 1, so this should be fairly easy to factor if it does factor. So let's quickly factor this, as you already know how to do that. Multiply to an x squared, so I have to have x and an x. Multiply to a negative, my two numbers have to be opposite in sign. Multiply to negative 12, add to negative 1, so my numbers have to be negative 4 and positive 3. And if you FOIL this out, you'll get your original statement. So now I have it factored. Remember, you set each factor equal to 0. And then solve these little equations. X equals negative 3 and x equals 4. So these are my boundary points. Boundary points are points at which the original inequality can change from a true to a false statement. Once we have the boundary points, what we need to do is we need to plot them on the number line. So here's my number line. And so I have boundary points at x equals negative 3. So here's one. Hopefully it'll draw for me. There's negative 3. And my other one is at x equals 4. So what this does is this divides the number line into 3 regions. The region on the left, the region in between the two boundary points, and the region on the right. And once I've figured that the 3 intervals, all I have to do is test each region. So I'm going to pick a test point in each region. And so the first region I want is from negative infinity to negative 3. So all I need is any point in this region. I can't use the boundary point. I can use any point to the left. Well, the simplest is x equals negative 4. And since I've scrolled up, we can't see the original inequality. It was x squared minus x is greater than or equal to 12. So now I'm going to plug negative 4 into my original inequality. So is negative 4 squared minus x, which is a negative 4, is that greater than or equal to 12? I want to see if this is true or false. Negative 4 squared is 16 minus a negative 4 plus 4. Is that greater than or equal to 12? Is 20 greater than or equal to 12? Well, that is a true statement. So that means I want this region. I want the point negative 4 and anything to the left of -3 going all the way to -infinity. Since the only places that this inequality can change from true to false is at the boundary points, all you test is one point in each region. So during the pause, I wrote down what happens when you plug x equals 0 and x equals 5 into the original inequality. And as you can see, from when x equals 0, I get 0 minus 0, which is 0. Is 0 greater than or equal to 12? That is false. Therefore, I do not want this middle region. Last one, when I plugged in 5, is 25 minus 5 greater than or equal to 12? Well, is 20 greater than or equal to 12? That is true. So I want this region here to the right of 4. So I've nearly finished my graph. All I have to do now is come up here, look at my inequality. It's greater than or equal to. So I need to put square brackets on my two endpoints. And now I'm ready to write the answer in interval notation. This interval here on the left starts at -infinity. Remember, never put a square bracket on infinity or -infinity. To -3, square bracket -3. My point has to be either in that interval or, which in interval notation means a union, 4 to positive infinity. So there is my solution written in interval notation.